Hello, everyone. Good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 7A. I am Anisha Mishra, the moderator of this session on behalf of Global Knowledge Research Foundation. It is my great pleasure to welcome you to the 6th World Conference on Smart Trends in Systems, Security, and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. If you have any query or update, you can write it to me in the chat box. There's another request to all the participants that you please stay connected with us till the closing of the session. So just before we get started, I would like to introduce you all to the chair of the session, Professor Roshan G. Ragal. Professor Roshan Ragal is a full professor in computer engineering at the University of Peradeniya. He is a skilled university lecturer and researcher with a doctorate in computer science and engineering and a passion for teaching, research, and administration. His research interest is in the areas of fault-tolerant and dependable computing, accelerated and high-performance computing, wearable computing, and synthesis of secure and reliable embedded processors. Professor Ragal received his PhD in computer science and engineering from the University of New South Wales, Australia in 2007, and his BSc in engineering from the University of Peradeniya, Sri Lanka in 2001. He was appointed a senior lecturer in the computer engineering at the University of Peradeniya in December 2007 and a full professor since October 2017. Welcome to the session, sir.
Hello, everyone. Thank you.
Okay. So now we'll start with the papers. So our first presenter is John, and the paper title is Improvement of the Production Process through Simulation Models in a PET Bottle Manufacturing Company. Dear presenter, you may please start your presentation.
Yeah, hi. Yeah. Good morning, good afternoon, and good evening to the public present. My name is Milton Cordova. I am from Peru, and I am very pleased to have this opportunity to present our research work based on system simulation. Our research project is entitled Improvement of the Product Process through Simulation Models in a PET Bottle Manufacturing Company. We chose the authors of the present work. Plastics continues to be one of the most widely used materials in packaging as an equivalent to paper, glass, or metal. The low cost of plastic packaging promotes its use in large industries, making it a business with great impact. This is specifically note that in Spain, the production of plastic bottles accounted for 39.9% of the economic in the 2016. Likewise, the problem of bottlenecks, for example, in foreign territories, South and Spain, has severely affected economic. 70% of manufacturing companies were conditioned by shortage of raw materials and the resulting downtime in their production process due to insufficient capacity in certain areas of the industry. The flow of work was not continuous, and more time than necessary was spent on some process. This is the case in other containers. This paper presents a proposal to improve the process, which are affected by the boldness of the Peruvian company through a system simulation model in ProModel software. The objective is to improve the production process in order to reduce the problems that are exposed. For this purpose, the manufacturing process of the different bottles we will be analyzed. The problem identified is the duration of their process, which require more time than estimate. Specifically in the product flow of bottles for soft drinks of 350 milliliters and bottles for alcohol. The process the preset and preset either are not able to follow the continuous production flow. Do understand topics due the light companies and other reasons. As the workday USB bottlenecks are identified at various points in the production flow, which is after complies with the recurring demand in resource time. This is a study is classified as a described, quantitative, and cross-sectional research work, which helps for data collection. We use AppSheet and direct observation, and to process the data, we use StatFit and ProModel. We can see in the image that means of data collection, the AppSheet application and the direct observation data collection form. We can also see the ProModel software and the StatFit, which is an extension of the program with which we process the data. We can see in the tables the variables of the system with their respect distribution of product 1 and product 2. We see logarithm, uniform, and probability distribution with their respect degree of reliability. In table 3, we can see the process times in age of the location. The 4 describes the maximum capacity of each location. In addition to other characteristics obtained from the data collection technicals. This is information was processed in the specialty software ProModel version 7.0. Below is a representative diagram of the general production flow of the company. This is production process consists of two inputs. One of the terms is the warehouse of the caps, and the other is the raw materials warehouse. It describes all the process toward which the raw materials as to pass to final obtain the finished product. We will look at the process of building the model. 19 locations were created. In addition, the maximum capacity at each location was recorded. 8 entities were created. The term entities present the cyclical elements that were simulated. By creating the process, we can make a sequential order of the flow until the final product is obtained. Finally, the layout of the cause study is obtained with the application of the simulation model in the specialty software ProModel, as shown in figure. The squelette simulation time was 6 days and 5 rounds. The results obtained were found to be close to the company current situation. Among the other results of the simulation, two major problems is the production flow are shown. One of them being the low percent of the location utilization and the high percent of the time of the operator. These aspects have the negative influence, causing more downtime and delays in the rest of the production line. Bottlenecks at different points of the system. The locations with the lowest percent of the utilization of the resource are industrial clean machine with 1.47%, blowing machine with 2.62%, inspection area with 8.22%, pre-warehouse with 2.68%, and cap warehouse with 7.95%. The figures show the excessive waiting times that the entities are exposed to, which explains to the low percent for utilization in the respective work location. We have seen that machines, inspectors, loaders, and baggers have a high percent of initiative. In this way, the simulation show the excesses of the problems, of the true problems that influence the occurrence of the so-called bottlenecks and the low percents of utilization of the location and excessive idle time incurred by some operation, with particular effects the area in chase, as well as in general the continuity of the production flow. According to the half above, the following is proposed, and the more function to operation that were identified having high percentage of idle time, reduce the speed of the arrival so as not to generate many bottlenecks. I think better for producing line 1, their operation to support the Beijing area. In the following image, we can see the implement of the above mentally improved proposal in order to solve the mentioned problems. In the implementation of super machine in the production process of product 1, this is evident that basket 1 reduced its utilization to 69.78%. The badging machine utilization rate went from 0.72% to 45.088%. The capping area accelerate its shipment to the badging area, equivalent reverse impediment the increase in utilization percent with the alcohol badging machine increased by 55% and the blowing machine by 4.58%. The structure of the resource, I think the new work function help the increase their utilization percent. The worker earns under 100%. The budget went from having 0%. Utilization 228, utilization support to machine 1, machine 1.2, and the inspection of the both products increased percent of the utilization of 50.54% and the 9.55 respectively. After simulation, the implements to follow conclusions. No? Simulation employed, we come to the following conclusion. The pro-model application is the waiting time percent that reducing volumes the pro-model software provides results of the current system under study in order to mesh house, and they chose the alternative solution that improves productivity. With the efficient reorganization of worker function, the production flow of soft drink and alcohol bottles is optimized. Thanks for you. Thank you for attention.
Sir, do you have any questions for him?
Yeah, Anish. I have one question for you. Are you there, Milton?
Yes.
Okay. So the question is, you have presented the utilization individually for each parts. Do you have an overall performance improvement? Do you have any count or quantification of the overall performance improvement of the production process? Do you hear my question?
Uh, can you repeat the question to me
Yeah.
more slowly?
Yeah. So you have presented the utilization, operator utilization individually, right? So for 4 parts, you have said the improvements of operator utilization one by one. You have presented the performance improvement. Do you have an total number, like for the whole process, how fast you have or how much you have improved the whole process? A single number? We are not, you are not audible, Milton.
Yeah. Improve be 650 percent in the area of total projection.
60, is it? 60?
650.
Okay, fine. Thank you. Anisha, we can go ahead. Thanks.
Okay, sir. Thank you for your great presentation. Now we'll move further to our next paper, and the paper presenter is Renzo to present his paper on simulation model for the improvement of waiting lines in the customer service process in a swimming academy. Dear presenter, you may please start your presentation.
Good morning, good afternoon, and good evening. My name is Renzo Segura. I am a student at Universidad Nacional Mayor de San Marcos here in Lima, Peru. Today I am going to talk about our research project, simulation model for the improvement of waiting lines in the customer service process in a swimming academy. Our presentation has 4 parts: introduction, methodological aspects, results, and conclusion. Quizzes are part of our daily life in a various situation, such as when payment in a supermarket, buying a movie ticket, going to the bank, waiting for the crossing light to change, among other situations. We basically live in a world of queues. Having to wait is not an only personal annoyance. The time that the population of a country waits waiting in queues is an important factor about the quality of life and the efficiency of the economy. What time the client arrives and how long it's going to take to help him or her cannot be anticipated. However, the wasting time can be reduced or eliminated if the registration process is designed in an appropriate and organized manner. Normally in Peru, as in most countries, queues are present in many places. And now, as a result of COVID-19, there is an increase in waiting time to do safety protocols that include reduced capacity of the premises. Long queues are present everywhere. This situation is very evident in local swimming school located in Lima. After having suspended operation for almost 2 years, the school resumed its activity on January 2022, surprisingly observing greater demand compared to summer of 2020. Here in Peru, summer is from December to March. However, despite this growth in demand, dissatisfaction due to waiting times has been observed. Many potential customers, after waiting in line for some time, prior to leave, which cause a potential arrival loss of business. Adding more customer service modules to improve service could mean an investment in equipment and additional personnel that the school may not be able to afford. Also, during the not so busy times, there is not enough work to keep additional workers busy. On the other hand, maintaining a single model drives away customers due to the long waiting time and also adds stress to the staff. In the image, we can see how the current system is in a how queues are generated outside the premises. Now, we ask ourselves, how could we improve customer service in terms of providing information, enrollment, and payment process with an analysis of waiting lines? What are the factors that affect customer service time? How does the distribution in arrival rate and service time influences the waiting lane model? How does the simulation model of the waiting system help us analysis and propose improvement for this problem? In this section, we will see the methodology of this type of research, the research or participants, the procedures, and the analysis of the information. The research is descriptive, quantitative, and cross-sectional because its main objective is to describe the management of waiting queues in a swimming school, where the waiting system was analyzed and relevant information was collected to determine probability distribution of the following study variables: time between arrivals, time between calls, time to provide information to customer, time to register, and time to process payment. The often the data for four groups were analysis. Each made up of 25 face-to-face clients and 25 phone clients. From these 8 samples, information was collected of the age of the relevant variables under study, of which we wanted to know probability distribution necessary to process the simulation model. The collect information, the premise for the visit for 4 days, and we observed the client participation and behavior. After which the data collect was organized in Excel chart like this one. Here you can see an example of the service time variable. For the data analysis, confidence intervals were created for the means of each of our variables. That is for the sample mean of the time between arrivals, time between calls, time to answer customer questions, time for registration, and time to pay with the level of 95% confidence. Then describe statistics of the variables were calculated using Minitab 19 software. As mentioned, relevant described statistics were calculated for the analysis of the information collected. And static inferences was also used to determine confidence intervals for the statements made with a confidence level of 95%. The table shows the described statistics of the variables of interest and the confidence intervals of the fluctuation of the mean. We can observe the results produced by Minitab, where the estimation of the distribution of each variable is found. As you can see on the table, the exponential distribution or the Weibull distribution can be assessed for the checkout time variable. Since the p-value of the distribution are higher at the level of signification 0.05. Therefore, it was analyzed using the Anderson-Darling statistics, which tells us that the distribution that best fits is the one with the lowest value of these statistics, having to be substantially lower. An app observed the comparison of the statistics between the distribution exponential and the Weibull distribution that not occur. Therefore, other criteria had to be applied. In this case, we will resort to graphical analysis, which is shown in this graphic. I can be seen that the distribution that best is the data is Weibull distribution. Therefore, the null hypothesis is not rejected, which says that the time it takes to pay follows the Weibull distribution. The table shows the sample proportion of the frequency distribution for the number of people that register at the swimming academy. This way, the confidence intervals were built with the help of the Minitab 19 software to determine the probability that a client would join the school. Therefore, the probability that a client would join is 0.77, fluctuating between 0.69 and 0.84, with a confidence level of 95%. With the data already processed, we use the ProModel software to model and simulate the current procedures and the proposed improved process. ProModel is a special simulation software that evaluates plans and redesigns process. As we saw a few minutes ago, this is the current procedure used in the swimming academy. We can see the process in the flow chart. We can see that there is an associate helping a customer at a single point, and at another point there is another association collecting the payments. The process begins when a client enters the premise or calls for information come in. If the customer service clerk is free, information is provided. Other ways, the customer waits in line. After the information is provided, there are two alternatives. The customer registers and goes to the cashier or leaves the premise. Looking at the current situation of the swimming academy, 30 runs were simulated for the period between 8 a.m. and 6 p.m. The arrivals includes both clients in person and the phone. After ProModel simulation, an average of 31 clients for help of those 24 registered in the school, and additional 28 calls for answer. Also, for both affiliate and not affiliated clients, a great difference is observed between average time this person spends in the system and the average time he or she spends in the actual operation, which leads us to the objective of this study. With the results, we can identify a bottleneck in the service area. The difference between average time in the system of an affiliated client and a not affiliated client is very little, contrary to the difference between the average time in the system and the average time in operation. Therefore, we can conclude that the delay is not in the payment area. This is also reflected in a percentage of activity and inactivity of these two locations as shown here. Following the data obtained in the simulation, the proposed solution was to cross-train so that both staff members can provide customer service in person and the phone and collect payments. This is due to the fact that bottleneck was observed in the customer service area and a low percentage of your cashier area. For the application of this proposal, the graphical...
Sorry for the interruption. You have only 1 minute left. Please conclude your presentation.
Okay. In addition to marine fine location and process data interview in the change. After second simulation with accident parameters to initial one was done, an average of 30 clients with help, of which 25 registered and additional to answering 27 calls. Although number clients helped or register not change significant, and to say that new model had some impact to aspects. For this reason, it's considered that fees proposal is an appropriate alternative to the Swimming Academy, since the reduction of customer service time achieved could mean in the describing the loss of potential clients due to delays or unwanted queries. Management will have to determine if a cost of training personnel and or buying equipment and furniture would merit improvement. This project, when applied to a local swimming school, may serve to bring the university closer to small and micro businesses, as this funding could be applied to other local enterprises, and at the same time provide a positive impulse in a national economy, helping diminish improvisation and the high degree of uncertainty this causes. Thank you for your attention.
Thank you, Renzo. I'll start with a question or two and then I'll let others ask. First thing, have you tried this model out in the real swimming pool setup or have you not? Did you try it out?
Yes, in a swimming academy.
So the simulation numbers and you have done the simulation and then you have tried it out in the real swimming academy. Are those numbers similar or do you have a difference?
They're similar.
Okay. And just one more question. You have used a certain number of samples. If I'm right, somewhere around 100 data points, 120 or some number you mentioned. How many samples you used? 120, 100 or some number, right? The number of samples for the model.
Can you repeat, please?
How many samples did you use for the data modeling?
About 100 or 2.
Yeah, so my question is, will your model be better if you use more samples? Have you tried, if you use more number of samples, will you get a better results?
We have to test it.
Okay, thank you.
Thank you.
Good work, interesting.
Thank you for your great presentation. Now we'll move further to our next presenter. The presenter name is Zineb and the paper title is Green Hydrogen for Industry, a proposed approach to manage the flow of energy in industrial sector in Morocco. Dear presenter, you may please start your presentation.
Hello, everyone. I'm Zineb Slawi and I'm Moroccan. I'm going to present you my project called Green Hydrogen for Industry, a proposed approach to manage the flow of energy in industrial sector in Morocco. I will start by introduction, research objectives, green hydrogen production, energy consumption in Morocco, and green hydrogen usage in Morocco. Important projects in Morocco, hydrogen production techniques, and the energy management algorithm, including green hydrogen production. And finally, I will finish by conclusion. Worldwide warming could be a critical concern that requires for clean energy generation with aim of reducing carbon on the global climate. As the world's population grows, research have focused in the present decades on harnessing renewable energy research to meet clean and less expensive energy demands. Green hydrogen is considered the clean energy of tomorrow, as it is produced entirely from renewable sources. Morocco is one of the countries interested by this type of energy and started projects to produce green hydrogen and use it, especially in industrial sector. The appearance of renewable energy, wind, solar, biomass, seemed as a hope for humanity, but science, they are subject to intermittency. Within the no appearance of wind and sun, the production of electricity is troublesome. On the other hand, when there as will match, it causes a surplus of energy within the network. So the solution is for this problem is green hydrogen. This research consists on the following, showing green hydrogen usage in different sectors in the country of Morocco, presenting different techniques for hydrogen production, proposing an algorithm to manage the energy in a hybrid renewable energy system, including hydrogen production. Now we see energy consumption in Morocco. A large part of Morocco's energy consumption is still based on fossil fuels. 31% on crude oil, 17% on coal, 4% on natural gas. Green hydrogen in Morocco. Morocco is one of the countries investing in a project to produce green hydrogen for renewable energy. For the last 10 years, Morocco has served as the regional champion in clean energy. Morocco is a country rich in renewable energy. Now, green hydrogen usage in Morocco. This table summarizes the estimated of electricity potential demand in Morocco in different sectors. As we can see from the table, electricity demand in both the industry and the transportation sectors between 2030 and 2050 remains very high. It's estimated that a green hydrogen industry and its derivatives in Morocco could face a demand between 13.9 terawatt hours and 31.1 terawatt hours in 2030, which could reach between 67.9 terawatt hours and 132.8 terawatt hour in 2040 and 153.9 terawatt hour and 307.1 terawatt hour in 2050, depending on the scenario. We have therefore focused on the industrial sector first. Now we will see important projects in the Morocco. Important projects are already on the site in the Morocco in the country. First project undertaken by Mazen as part of a Moroccan-German partnership. The primary objective of this project is to supply a green hydrogen plant, which electrolysis capacity of approximately 100 megawatts by building hybrid photovoltaic and wind power plants. The second project, the largest green hydrogen and ammonia project called EVO Ammonia, Morocco, was recently unveiled by Mazen, also with an estimated total investment of over $850 million. Now, green hydrogen production. For the production of dihydrogen H2 and the main resources exploited are water and electricity for renewable sources. This hydrogen can be started in several ways, liquid or gas forms. Green hydrogen generation is heavily influenced by the irregular behavior of a renewable generator, where it entirely derives from. Now we will see three techniques of hydrogen production. The first technique, steam natural gas reforming, involves reacting methane with water to obtain a mixture containing hydrogen. Electrolysis of water, the electrolysis used to split the water molecules into hydrogen and oxygen by passing an electric current. Gasification, produced by combusting a mixture of CO and H2 coal. Frequently, the best method to produce hydrogen without greenhouse emission is via the process of electricity of water using, of course, renewable sources such as wind or solar energy. And now, hydrogen produced by electrolysis of water is a technique that breaks down with a supply of electricity the H2O molecules into dihydrogen H2 and oxygen O, and the electricity provided is itself electricity from renewable sources. Energy management algorithm including green hydrogen production. Now we will see the algorithm. The energy between the input and output sources in the hybrid renewable sources system will satisfying the load demand in the difference between the data generated by the input sources and the load should be calculated at each period of time. This difference is represented by P net. The net power can be either positive. The power generated by the renewable sources is fully satisfying the load demand, or negative. The power generated by the renewable sources cannot fully satisfy the load demand. If P net is positive, there is an excess of energy that should be stored in the batteries. The batteries should be charged to maintain a longer lifetime for batteries. The batteries SOC should stay less or equal to 80% of its capacity. If the battery is still full, then the hydrogen can be generated and the hydrogen batteries can be filled. In the case of SOC and SOC max, the battery can be filled and the rest PF energy can be used to produce hydrogen and store it in hydrogen batteries. In all cases, the produced and stored green hydrogen can be used when P net is negative and the battery are fully discharged. To summarize all what we have seen before, reduce the consumption of electricity remains a primary objective in the industry sector, given that demand for electricity remains very high in this sector. Green hydrogen is among potential all alternative energy sources and a solution to manage the industry flows in the future. An algorithm to manage the flow of energy in a hybrid renewable energy system, including green hydrogen production that can be placed within a factory was proposed. The energy production technique that was chosen was the water electrolysis to make sure that all the hydrogen produced in industry is green. In our future work, the algorithm presented will be implemented on the basis of intelligent method to control the energy produced by sustainable energies that will lead to the reduction of CO2 in industry. Thank you for your attention.
Thank you, Sint. I have actually one question. One is in your slide 6, you were showing the energy consumption of different sources. I see like it's about 50%. The balance, where is it coming from? Is it clear?
Yes, can you repeat, please, the question?
Yes, the slide 6, on your slide 6.
Yes.
You have mentioned about the energy sources for Morocco. You have mentioned different sources, but I see it's about 50%. Is it the balance? Is it only the fuel you are presenting there, fuel energy? On slide 6. Can you go to slide 6? Slide number 6.
Yes, the the 31% on cold whale, 17 on coal, 4% on natural gases.
So it is not adding up to 100, right? So where is the balance? Yeah, that. So is it only from the fossil fuel? The rest are the renewable energy, the balance. The total here is about 50%, right? Do you already have renewable energy for the rest 50%?
Hi, good morning. Can I answer?
Yeah,
can I
please.
answer instead of Zainab? I
Yeah,
am her
that's
supervisor.
fine. Yeah, please.
Hi, how are you? I'm Dr.
Yeah.
Fakir Sana, Zainab's supervisor. Yes, I think in this slide she's just presenting the large part of Morocco's consumption using fuel bases.
Fuel,
so
yeah.
the rest is either other sources or renewable sources. So these numbers, they present like 52%, which is more than the half of the consumption, but still the rest is either renewable or other resources of energies.
I'm just curious to know.
Does this answer your question?
Yeah, thank you very much. Yeah.
All right.
Just curious to know. Yeah, it's good. Thank you for the presentation. And thank you for you. Anisha, go ahead.
Okay, thank you for your great presentation. Now we'll move further to our next paper. The presenter is Yama. And the paper title is Isogeny-based Group Key Establishment Scheme. Dear presenter, you may please start your presentation.
Dear colleagues, my name is Anastasia, and I would like to tell about isogeny-based key management scheme. Group key management is an important functional building block for any secure multicast architecture and group-oriented applications. Historically, establishment of group key comes in two flavors called group key distribution and group key agreement. In the former approach, trusted third party or group key manager usually takes the responsibilities for choosing a group key, distributing it to the group members, updating and revoking. In the latter mechanism, all group members collaboratively calculate the shared key. An obvious drawback of key distribution scheme is an absolute trust on a single third party, such that the security of entire system will be broken in case the manager is compromised. In addition, there is the problem of secure transferring the group key to each member of the group. Moreover, the group key manager may become a bottleneck if the number of group members is large. So the network resource cost and time latency will be lower in these protocols compared to this in the key agreement protocol. And different from key distribution, all group in key agreement protocol, all group participants collaborate to derive the session key together. And so there is no need to have a key management center as a powerful entity for key agreement protocol. And the security channel doesn't need to be configured, and some failed members can be accepted during the negotiation process. The proposed scheme is based on key agreement concept in decentralized way. This means that users are divided into subgroups where group managers are allocated in each of them. There are many works devoted to group key management for secure communication, and most of them are based on either discrete logarithm and factorization problems that are vulnerable to attacks using quantum computer. The proposed scheme is based on isogenies of elliptic curves. As you can see from the slide, an elliptic curve of a field can be defined by a very stress equation, and this equation can be associated with a G invariant that doesn't change under linear transformations. A rational map phi from one curve to another curve, where infinity point on E1 goes to infinity point on E2, is called an isogeny. The previously proposed schemes on isogeny of elliptic curves can be divided into three categories, which differ in the type of curves, the computational problems used, and the parameters. Proposed scheme is SIDH based because they are characterized by a high speed of calculating isogenies. The proposed protocol is partitioned in two phases. First is called as initialization phase, and after that, the group key generation phase. At the initialization stage, the public scheme parameters are generated, and in addition, each group member generates a pair of keys, public and private. The private key is the value needed to generate the kernel of secret isogeny, and the public key is the curve into which the user moves under the action of this isogeny. The second stage is the authenticated key agreement phase. In this phase, manager authenticates all group members, then members contribute to generate a session key called group key. This phase also is partitioned into rounds, which you can see on this slide. At first round, the user group is checked, so it's like authentication of group member. It all boils down to testing a certain curve, which can be reached in various ways, as shown in the diagram. The second round generates a group key for all verified users. Thus, in the proposed protocol, each client equally contributes to compute the session key with the help of trusted group key manager. The proposed protocol is optimistic, that is, it implies trust in the group manager. The process of establishing a group key itself requires a lot of computing power from the group manager. table on the slide shows a summary of the number of operations required at each stage. The security of the proposed protocol depends on computational supersingular isogeny problem. The adversary cannot calculate the group key because he receives only a G invariant of elliptic curve that is calculated from the random secret. And the adversary can find the session K due to the hardness of isogeny problem. Since the number of operations performed by the manager depends on the size of group, this scheme has restriction on the size of group, which must be taken into account based on the computing capabilities of trusted party. Also, a significant drawback is the fact when deleting a member of the group, it is necessary to regenerate the common key of the groups by performing steps from 6th to 9th of the second round of the protocol. But this is injures forward secrecy. Further work consists of more detailed security analysis of proposed scheme, as well as possible scheme optimization. That's all. Thank you for your attention.
Thank you for the presentation. I have one question. How the scheme you proposed is going to be useful in a certain any application? Do you have an example application?
The application of such scheme could be some multimedia conferencing and multi-user interactive computation. So like group-oriented computation.
Thank you. Good presentation. Thank you.
Thank you.
Thank you for your great presentation. Okay, now we'll move further to our next paper. The paper presenter name is Devar, and the paper title is Bibliometric Analysis on the Smart University Concept. Dear presenter, you may please start your presentation. I think he is not in the session. Okay, so we'll move forward to our next paper. The paper presenter name is Jesus Gerardo Torres Vega, and the paper title is Towards an Intelligent Electric Wheelchair Computer Vision Module. Dear presenter, you may please start your presentation.
Okay, thank you. Hope you can see my screen. Okay. Good morning, everybody. My name is Jesus Gerardo Torres Vega, and I'm here to talk about the article Towards an Intelligent Electric Wheelchair Computer Vision Model. The agenda is as follows. I will first begin talking about disabled population. After, I will present the state of the art in intelligent electric wheelchairs. Then I move into the proposal solution, the intelligent electric wheelchair architecture. After, I will present the computer vision model, that is the main topic of this article. After, I will present the results and conclusions, and I will give some time for questions. There are more than 1 million of disabled people around the world. From this population, the 19% exhibits mobility disabilities. Only in Mexico, there are more than 6 million people, disabled people. From this population, the 48% exhibits problems for walking, going up or going down. From these statistics, we can see that mobility are the main disabilities, not only in Mexico, but also representing a major population around the world. The state of the art is focused on intelligent electric wheelchairs that use deep learning techniques. From this analysis, we found different approaches, such as which solutions uses images as data input, the type of environment where they perform the best, if they uses embedded hardware, if they use object recognition, if they use a proper obstacle avoidance technique, and if they measures their performance. From here, we recognize that the best features that we can choose is the type of environment where we can continue, for example, the indoor environment, the approach that embedded hardware systems, object recognition, and obstacle avoidance are the best features for this project. From this, here is also important to mention that images and data as data input used through convolutional neural networks have demonstrated a good performance. The solution proposed is to develop an autonomous driving system that is an intelligent electric wheelchair. But what is exactly an intelligent electric wheelchair? Well, it's a type of vehicle capable of navigate autonomously without collide. It is also capable to be aware of the objects that are around it, and also the objects or the obstacles present along the predefined trajectory. This intelligent electric wheelchair is also capable to identify objects of interest for the user, for example, medications or personal stuff. This proposal solution is intended to help handicapped people to give them back most of their autonomy, reduce assistance needs, and perform in an indoor environment. The architecture proposed is composed by 4 modules. The main module is the intelligent system. In this case, this system or this module receives the instructions from the user. For example, if the user has a touch panel, or for example, the instructions comes from voice commands, this module is in charge to receive the command from the user and order the other modules where to go. It is also in charge of control the data flow from among the 3 other modules. The navigation module is in charge of localization of the wheelchair and how to reach a destination. The joystick controller is in charge of adapt. Well, in this case, we're trying to adapt a physical controller that can move autonomously the wheelchair. Most of the wheelchair has a joystick attached to it, so we can adapt a kind of physical controller that can move the wheelchair autonomously. And finally, the computer vision module, that is the main topic of this article, is in charge of acquire, adapt images, and identify objects present in the environment. Well, I will talk now about the computer vision model. As I said previously, this model is in charge to identify objects present in the environment. This model uses pictures from the camera. The camera is attached to the wheelchair. These images are sent to an object detector that is WS4. WS4 is an object detector based on convolutional neural networks and is used to classify objects present in the image. It is intended also to use stereo vision cameras, so we can calculate the depth of objects present in the image in order to help the navigation model. Now, in this computer vision model, we have 2 main challenges. The first one is which are the best features of a camera that makes YOLO perform the best. And the second one is we need to use an embedded system. For the first challenge, we did a comparison of 3 different cameras. The first one is the IDS camera, the second one is a common webcam, and the third one is the Intel Real Sense. All of them have different features, as we can see in the pictures. And for this study, we created a data set of 33 images where we are classifying 20 different objects that are found in indoor environments. And we use them to find which is the best camera of the 3. We find which is the best camera of the 3. We find which are the best features that makes YOLO perform the best. The second challenge that we have is use an embedded system design platform. In our case, we're using a Latte Panda Alpha. Here's a simple schema of how this is working. We have a camera we have the 3 cameras that take pictures from the environment. After those pictures are sent to the embedded platform, YOLO is installed inside a Latte Panda, and using the object detector, we can predict the objects that are present in the image. We can classify them with a certain confidence value. But now, how we can find which is the best camera? We need something to measure this. We are using mean average precision. That is an evaluation metric used in object detection. In this case, to calculate mean average precision, we are using intersection over union and the confidence value. Intersection over union is the area of overlapping between the ground truth, that is, for example, in this case, the green rectangle, and the prediction of the object, that is the red rectangle. The prediction also has a confidence value, and using this and the intersection over union value as thresholds, we can calculate the precision and recall. Now, to calculate the average precision, we are calculating the area under the curve recall precision, and after, to calculate mean average precision is the mean of all average precisions from each object in each image, and these calculations are repeated for the 3 cameras. Now, the results that we found here, the IDS camera exhibits the best performance of the 3. In this case, the important features found were high resolution images, a color format of the image, and a CMOS color sensor that is attached to the IDS camera. In this case, our IDS exhibits a 0.70 value of map. Right away, the perfect choice also exhibits, perfect choice is the common webcam, exhibits also a good performance, and Intel Sense is not the best of the 3. Another important result is that we should take into account the average time in seconds, because we are talking about real-time precision, real-time prediction, sorry. In this case, although the IDS camera has the best map value, the average precision in the average time is not the best. So in this case, Intel Sense have demonstrated to succeed in have a better average time in seconds, but it's not the best of the 3. As a conclusion, we created a new data set using the 3 different cameras. We created a data set of 33 images. We are analyzing using the map metric and the object detector YOLO before. We created the ground truth for the data set, and we are running YOLO before on an embedded system design platform that is Latte Panda. The best camera of the 3 is IDS, as I said previously, an RGB format of the image, a high resolution image, and also it exhibits a poor prediction time. This is all from me. Thank you for your time, and I will be here if you have any question.
Thank you for that presentation. This is it's an interesting project, and what I wanted to know is one, why do you want autonomy on a wheelchair? I understand autonomy on a car.
Yeah, no, we are talking about this because we can modulate a wheelchair like an autonomous vehicle.
Yeah.
In this case, we have many research focus on autonomous vehicles, and why not talk about an electric wheelchair? Because at the end, it's a vehicle for a person.
Okay, but yeah, right. So I'm still thinking about it. Thanks. The next one is it looks like you have tried a YOLO. Was it YOLO 4 or what's the version you used?
Yes, YOLO before.
Version 4. So it looks like you have just used YOLO and object detection on an embedded device. That's the main challenges. How is it connected to a wheelchair? I mean, I know, like, I understand that wheelchair, you're going to put this on a wheelchair, but you are focusing more on object detection and applying it on a embedded device, right?
Yes.
So wheelchair is an example. You can use the same system in several other places, if I'm right. Is that correct?
Yes, we can use this approach in different devices. In this case, this is the application because we found this. Well, in Mexico, it's a major field about the health field.
So do you have some have you tried it out? Is it on a practical level, or is it just the module build and it's at that stage? What is where is it now? I mean, in terms of a project.
It was only tested on the Lat Panda as I presented in one slide.
So not like on a production level,
not yet, because there are other teams working on at the university on the other models that, for example, navigation, for autonomous navigation, and we are still working on that.
Thank you. That's an interesting project, and I like the idea. Yeah, but I'm still thinking about the wheelchair autonomy. Yeah, thank you.
Thank you.
Thank you for your great presentation. So now all the papers have ended. I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 5th version of the conference. We will be happy to have you in the 7th version in 2023. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4. I also like to thank our session chair for chairing the session. Here is a token of appreciation on behalf of the team of WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you.
Okay, so as we have come to an end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much. Stay safe and take care.
Thank you. Thank you, everyone.
Thank you.
Thank you.
Thank you.